Hello, welcome to Aircraft Maintenance Practices Unit 5 lecture. This lesson, we will describe the purpose of safety lock wiring, identify different kinds of safety wire and their usage, list the tools to be used for safety wiring, describe the procedures to install safety wire, describe the procedures to wire typical parts in aircraft, outline the rules for safety wiring. Last but not least, also carry out safety procedure on fasteners for using lock wiring, cotter pins, and tab washers. So this picture typically shown the type of lock wiring applied on different fittings and fasteners. Right. Why do we carry out lock wiring or safetying? Lock wiring or safetying is to prevent fasteners or fittings from working loose due to vibration, shock, airflow or flexing of the airframe or component. There are various methods to prevent the fasteners to work loose. Safety wiring is one of the very common methods applied on aircraft maintenance. Safety cable is not that popular, but is subject to manufacturer approval to apply this method on their aircraft manufacturing work. There is a YouTube link here that show you the difference between safety cable and safety wiring. Of course, verbally I can tell you safety cable is fast in terms comparing to a safety lock wiring carried out by a technician. But of course, when anything that comes with fast and convenience is always about cost. So safety wiring cost, of course, compared to safety cable will be slightly cheaper, or there's no charges because you only buy the raw material and the technician will carry out the work. Alright, so feel free to look at the link and understand safety cable. And we have cotter pins, tab washer, lock plates, which we will cover in later part of the slides. Special nut, spring lock washer, and spring pins are also available for safety methods to prevent the fasteners or fittings to come loose. So there are various locking devices available. Other than lock wiring, the other most common method to use to prevent the fastener to work loose will be split pin, alright, or cotter pin. Do take note that split pin can only be used once. Once you bend it to this condition, you have to discard it. Okay, we will talk more about split pin in later slides. And you have another one is called tab washer, also used once. So not permitted to straighten the tab, we use it. So once or time we remove the nut, you have to unbend the tab leg and loosen the nut. So when you want to reinstall back, you have to get a brand new tab washer. Okay, lock plate is also another common method to use to prevent the nut to work loose. And the other one that is not very popular or current aircraft manufacturing, spring washer and shake pull washer are no longer in use because it tends to damage the surface that you mount on it. Alright, the other one is called center punching or burring. This is also not very common practice now. Alright, most of the time, if it was the case, they will use a lock plate method or split pin rather than a burring method. Safety lock wire is one of the very common methods used to ensure components or fasteners do not come loose. It provides positive and satisfactory locking effects. Method of wiring will depend on the threads of the fastener. 90% or in fact 95% to 99% of fasteners thread used on aviation are right hand threads. So any tendency of one unit to run loose is counteracted by tightening the wire. Alright, so during the practical part, we'll explain to you what we mean by this statement. It's easier to explain on the training aids. So There are various type of lock wire. It depends on the service conditions, the temperature, and the environment. Zinc-coated soft steel wire is general safety. Stainless steel is corrosion-resistant wire is when non-magnetic and low temperature environment. Okay, it's also used as general safety. Mono or inconel resistant wire is used where high temperature working environment, where up to 400 to 700 degrees for mono, inconel is above 400 degrees Celsius. Copper wire is actually a anti-sabotage wire. All right, it's used for breakaway ability, like fire extinguisher, prevent pilots from inadvertently activate the switch, so they use a copper wire to lock it. Later, I think there's a slide to talk about this. So most common lock wire diameter is 0.032 inch, the most commonly. All right, over here we have a picture of safety wiring. So what is the direction you need to apply? Before we apply, make sure that your safety wire is in the direction that tighten the components. So most of the time we have to check what type of threads these fasteners are. So it's left hand threaded or right hand threaded. All right. So let's assume that it's a right hand threaded fasteners. Most of the time, 90% is right hand threaded. So when we tightening, it's actually moving in clockwise direction. Okay, loosening is anti-clockwise. So this lock wiring, okay, the rule of thumb to make it a quick one when we do inspection, we always see an inverted S. Okay, let me get a pen. When a lock wire you see is an inverted S, all right, and not S, this is wrong. Okay, inverted S is correct. We call it anti-Superman wire lock. What do you mean by that? Okay, let's go back to the lock wire here. So if my bolt is working loose due to vibration, it will turn anti-clockwise. Yes, it will turn anti-clockwise. So when it turns anti-clockwise, based on this lock wiring method, the NTS, okay, the tendency of that action will cause the wire, when the bolt turns anti-clockwise, it will actually pull the wire. Correct? When it pull the wire, in this case, when it pull the wire, okay, I use another color lah. Let me erase this. Okay, I use another color, it will be easier. Okay, let me use red lah. When you pull right, when it working loose, the tendency of that when the wire is attached to the bolt, it actually pulling this lock wiring. Correct? When you pull the lock wire, the tendency of that is asking the bolt below to move in clockwise direction, which is tightening. So if the lower bottom bolt is already tightened to a required torque value, it can't move further. So apparently when this top bolt itself try to work loose due to vibration, the wire will actually be pulling this bottom bolt, and if the bolt cannot move, the lock wire won't be able to stretch, and it won't be stretched no matter how, this bolt will not come loose due to vibration. That's a simple lock wiring. So if it's a S, if you see this is a S. You see this? That the lock wire is S. All right. This is the inverted S. If this is the S type of lock wiring, you will do it this way: vibration, anti-clockwise, trying to make the top bolt to come loose. So anti-clockwise movement, right? Because I want. All right. MS20995 NC32. This is the part number you want to order from the material supplier. So let's say if I need a MS20995-NC-32, it tells me a lot of things. MS stands for military specification, quite similar to my revert MS, military standard. So what is 20995? Actually, there are various number here, 20995, where CNCNCY. What does it mean? Actually, NC represent mono. Yes. If I want a 304 stainless steel, instead of NC, it will be a dash C. Can you not see that? And N is inconel, and if it's CY, will be cadmium plated copper. The copper CY. So if I want a CY, it will be MS20995 CY. Okay, I'll replace it with CY. Then what is 32? 32 is actually the diameter of the wire. So if let's say I want a 25, there's a 25 on the market. So 25 of course smaller than 32. So what do you mean by 25, 32? Actually it's 0.025. Okay, it's stated here 0.025. Then this is 0.032. Okay, so 0.032 is a very common diameter. Right, 0.412 is primary turnbuckle, where it's critical. The thicker the wire, the more difficult it is for lock wiring twisting. So, all right. Give you a few moments to read through this, then I move on to the next slide. So do take note that how do you know which type of wire is this? Every lock wiring on top here you can't see, or if it is a container, there will be a part number MS20995, NC32, or whatever selection you have we printed here, so you know. Tools for safety wiring. Needle nose plier is this. All right, it's quite similar to duck bill plier. It's just that it's more sharper. Okay. So safety glasses, goggle. Please make sure that use this PPE when you carry out lock wiring practical. We do not want the lock wire, which is very sharp at the tail end, to poke through your eyeball. Okay, side cutter. This is a side cutter, it's known as snip. And of course, a safety wire plier is a very good invention to assist the technician to carry out twisting of the wire. I would suggest that during the practical session, we do a demo, then you understand how do we carry out lock wiring using this safety wire plier. So there are two methods for safety wiring. One is single wire, the other is double twist. Double twist is the most common method used. So it depends on the type of hardware, the application, the requirements of a maintenance manual. So have a quick one. This will be a single wire method, and this will be a double twist lock wire method. Double twist method for single lock wire, as shown here, double twist, is a preferred or most common method used. The twist should be even, smooth, and should not kink. What is kink? During practical time, you may ask the instructor, what do you mean by kink wire? So depends on the wire diameter. Okay, 1 inch will be 6 to 12 twists. Okay, per inch will be 6 to 12 twists. Most of the time will be under or over twist. Depends on the wire diameter, I say again. So small wire, which is 12 twists per inch. Medium, which is the most common, 0.0 wire diameter, 8 twists per inch. Large wire, 0.041 will be 6 twists per inch. So end of day, we finish the lock wiring with a so-called pigtail. It's just a term, pigtail, which is about 1/4 to 1/2 inch long, 3 to 6 twists. Then you bend it. You bend it inward because the end here is actually quite sharp. So you bend it inward to prevent people from getting cut by the tail of the lock wire. Okay, maximum bolts for double twist method will be 3 itself. Okay, 2, 3, not more than 4. So if the configuration is 4 bolts, then you have 2 bolts per lock, right? And the bolts should not be more than 6 inches apart. So this will be the designer will have to take note. The design. Single wire method as shown here. This is single wire method. Not very popularly used. Only when specified by the manufacturer. So maximum, just take note, is maximum length is 24 inches, 600 mm length of wire. So if you are able to lock the whole thing within 24 inches, then this is okay. If it's too long, then you have to find way or means or seek advice from the manufacturer, right? This is the one I mentioned about guarded switch meant for emergency. So it is lock wiring to prevent sabotage. This is a lock wire portion. Okay, there's a hole on the switch to pre and during emergency time, let's say it's a engine driven pump or the fuel pump, let's say emergency, or you want to jettison fuel to prevent inadvertent mistake. Is a double action to make sure that the pilot knows that what they are doing. In other words, if I want to jettison the fuel, all right, it's an irreversible process. I want you jettison away, the fuel will be out. So to make sure the pilot knows what they are doing and jettison correctly, they will have to do two steps of activation. One is to open up this guarded switch, which is held by this lock wire, and push the toggle switch, in this case hidden, to activate whatever systems they wanted to. So your lock wiring material used should be copper. Reason so is it breaks easily. Okay, it breaks easily. But if you use stainless steel or mono, any other than copper, then during emergency time, the pilot will panic because they do not have any cutter in the cockpit. And with a stainless steel wire lock, they are unable to break it by flipping the switch. Alright, a copper wire can, when you flip the switch, you should be able to break away the copper wire. So that is the reason. So please remember, make sure that you use the right type of wire for the right application. Alright, this is for during practical part. Remember I talked about the inverted S, anti-Superman. So this is the shape you want to achieve at the end of the day, inverted S. Alright, I wouldn't want to run through it here during the theory. During the practical time, the demonstration will give you a better insight how to carry out lock wiring. Alright, so I'll move on. There's actually a video clip subsequently I'll show you. Okay, methods commonly used in safety wiring on fasteners. Alright, so I mentioned it depends. This is the most acceptable methods. Okay, this method, you look at the wire here, the wire go over the nut side, okay, or the both side, depends. I think this is a nut side, yeah, castellated nut. This was subject to approval of the maintenance manual. If the maintenance manuals show you this picture, number one, you only can carry out this type of lock wiring. It is illegal or wrong approach if you were to do number two. So everything will depends on the aircraft maintenance manual. Alright, same things, make sure it's 6 inches apart, maximum 3 bolts in series. If you have 4 or 5, then it will be 2, 3 or 2, 2, depends on the setup. It can be a single fastener. Just make sure that it's inverted S. You can see it's an inverted S. Alright, so single wired, 24 inches apart. Castellated nuts, we'll talk about it. Currently, this is shown by using lock wiring, but most of the time, if it's a castellated nuts being applied, most of the time, split pin will be used instead of lock wiring. But then again, if the aircraft maintenance manual mentioned that lock wiring and in this method, then we will carry out lock wiring. Everything follow the manuals. These are some examples used for lock wiring. So it's very commonly used and popular ever since the very first commercial aircraft till now. I believe they started lock wiring till now. Alright, these are the video link. You can use the QR code to scan and the videos will play. So this is the lock wiring carried out on a propeller boat. This is just a training videos to show you how lock wiring is being carried out and what type of tooling is available for lock wiring. If not, if you want to click the link, then you can go to the Blackboard Learning Resources, term 1, lock wiring slides, and click from that slides. Alright. So this is a summary of general safety wiring rules. I would not want to run through these individually. You can read this up from the slides which I mentioned in Blackboard Learning Resources term 1. or is available in your textbook. Okay, so I give you a few moments here to read if you want to. Okay, let's move on. This. Okay, this is the approved commonly used method for split pin insertion. For this, it's subject to the manual or manufacturer approval. So if the manual did not stipulate that such arrangement is allowed, please do not use this method, right? Please remember that, it's very important. Okay, so this is a quarter pin with Kelvis pin for shear application. All right, we have come to the end of the slides presentation. All right, I will see you during the practical session to further enhance your knowledge on lock wiring and split pin usage. See you.